Next topic, determination of describing function nonlinearities. That is, we need to find out the describing function of nonlinearities like relay, dead zone and saturation. In module 5, we need to study the describing function of relay, dead zone and saturation. Relay is an example for intentional nonlinearity that are deliberately inserted into the system, and dead zone and saturation are examples for incidental nonlinearity or inherental nonlinearity that are nonlinearities which are already present in the system. So determination of describing function, that is we need to find the value of Kn of relay, dead zone and saturation. Before going to derive the describing function, just a review for describing function, that is describing function Kn of x omega equals y1 by x angle phi 1, where y1 equals root of a1 square plus b1 square and phi 1 equals tan inverse b1 by a1, and the coefficients a1 and b1 can be found out by using the equation 2 by 2 pi into integral 0 to 2 pi y sin omega t d omega t, and b1 can be found out by 2 by 2 pi into integral 0 to 2 pi y cos omega t d omega t. Okay, this describing function can be represented as Kn of x omega or Kn. Next topic, describing function of ideal relay or on-off controller. First we are going to study the describing function of relay. Relay is also known as on-off controller. That is, it is a figure of relay. In the case of relay, the relay is turned on at this point and it has a value of m, and it retains a value up to the time when it is turned off. Therefore, the ideal relay produces an output like a square wave as shown in figure. That is, it produces, if we are considering the input x is equal to x sin omega t. Also, this ideal relay is an extreme case of saturation. Why relay is called extreme case of saturation? Just go through this slide. In the case of saturation, the output is proportional to input for a particular value, and after that the output is constant in the case of saturation. If this linear part shrinks to 0, if the linear part shrinks to 0, the output like this, and this output is equal to the output of relay. That's why ideal relay is an extreme case of saturation. So ideal relay is the extreme case of saturation because in this saturation the linear part shrinks to 0, produces the ideal relay output. When at omega t is equal to 0, the relay is turned on and it has a value m, and it retains the value at equal to pi. At omega t is equal to pi, the relay get turned off. Therefore, the output of relay produces a square wave having amplitude m. Is it clear? The output y has a value of m up to 0 to pi. That is y equal to capital M. That is m is the magnitude. Y equal to m, 0 less than omega t less than pi, and equal to minus m, pi less than omega t less than 2 pi. Okay, the output of the relay y is equal to m, 0 less than omega t less than pi, and minus m, pi less than omega t less than 2 pi. That is, this relay has a value of value of m, 0 to pi, and minus m from pi to 2 pi. Next, we need to find the describing function. For finding the describing function, we know that y1 is equal to root of a1 square plus b1 square. So first find the value of a1. a1 equals, the general equation is a1 equals 2 pi into integral 0 to 2 pi y sin omega t d omega t. But here we write that 2 by pi into integral 0 to pi y sin omega t d omega t, because from the figure it's clear that it exhibits half of symmetry, that is upper half, consider the upper half and lower half. This lower half is the mirror image of upper half, that is it exhibits symmetry, and 0 to pi its value is m and pi to 2 pi its value is minus m, that is it exhibits half of symmetry. So we need to integrate it from just 0 to pi. Therefore the equation becomes 2 by pi into integral 0 to pi. Otherwise we do 2 by 2 pi into integral 0 to 2 pi. Therefore here it exhibits half of symmetry. Therefore a1 equals 2 by pi into integral 0 to pi y sin omega t d omega t, and 2 by pi into y. What is the value of pi? The value of pi is 0 to pi. The value of y is m. So substitute the value of y as m. So 2 by pi into integral 0 to pi m sin omega t d omega t. This m is a constant, therefore it equals 2 m by pi into integral 0 to pi sin omega t d omega t. Next, integral of sin omega t equal to minus cos omega t. Therefore 2m by pi into minus cos omega t integral 0 to pi equals, substitute the limits, 2m by pi into minus cos pi plus cos 0, upper limit minus lower limit, that is minus cos pi plus cos 0, that is 2m by pi into minus of cos pi equal to minus 1 plus cos 0 equal to 1. Therefore the inner bracket value equal to 2, that is 2m by pi into 2, that is equals a1 equal to 4m by pi. Okay, is it clear? a1 equal to 4m by pi. Next we need to find b1. Here b1 equal to 0, because if a system exhibits half of or quarter of symmetry, the value of b1 equal to 0. Therefore the value of b1 equal to 0. Next, kn. We know kn equals, describing function kn equals y1 by x angle phi 1, and y1 equals root of a1 square plus b1 square. Here b1 equal to 0. Therefore the equation becomes root of a1 square plus 0 equals root of a1 square, that is equals a1. So y1 equal to a1. We know the value of a1. Next, phi 1 equals tan inverse b1 by a1. Here b1 equal to 0. Therefore tan inverse 0 equal to 0. Next, describing function kn equals y1 by x angle phi 1. Substitute for y1. Here y1 equal to a1. Therefore a1 by x angle 0. That is phi 1 is equal to 0. Therefore tan inverse 0 equal to 0. Therefore kn equals a1 by x angle 0. Substitute the value for an. Then the describing function of relay equals 4m by pi. a1 equals 4m by pi, and this x, therefore 4m by pi x angle 0. Therefore describing function of relay equals 4m by pi x angle 0. The magnitude equal to 4m by pi x, that is this m is the magnitude which produces the relay, and capital X is the maximum amplitude. X is equal to x sin omega t, where capital X is the maximum amplitude of this sinusoidal signal. That's all about describing function of relay. This describing function of relay kn equals 4m by pi x angle 0. It's very important. We need to study the describing function of relay, dead zone and saturation, and the equation of describing function of relay is kn equals 4m by pi x angle 0. Thank you.